Seniors. Today we're going to start talking about the urinary system. Because so many of you are going to be gone and won't be able to make up the class, I'm going to kind of skip around a little bit because we're going to do this lab and while you're not here, and I will give you a chance to make that up next Thursday. On next Thursday is when we'll have our Chapter 15 test, the day before, well, the day that senior retreat starts. We'll have our Chapter 15 test, and then any time that's left over after the test, if you weren't here this Thursday, you'll have that time to make up the lab. Okay, so I'll make sure I have everything set up for you because you need a bunch of chemicals and stuff, which you can see if you open up the lab on dashboard. Okay. So I'm going to mess with you a little bit. So we're starting Chapter 15, the urinary system. We are not starting with Roman numeral 1, however. Okay, so Roman numeral 1 is about basic structure, and we'll come back to this on Friday. And so I'm moving Thursday's lecture to Friday and Friday's lecture to Thursday because there's some kind of important stuff that you need to know if you are going to be doing the lab on Thursday and turning it in on Friday. And it's due on Friday, I believe, at 3 p.m. if I remember correctly. Okay, so we'll talk about the basic structure of the urinary system, the functions, the gross anatomy of the kidney. So take a closer look at the kidney. All this we're going to do on Friday. Nephrons, those are the cells that make up the kidneys, and so we'll talk about those and what's going on with them. And we'll talk about urine formation and how that works in light of these structures. But for today, I'm actually going to skip out of this and take us to a new outline. So this is kind of small. I guess we could blow it up. Even on your iPads, it might be a little too tiny to see. Ah! Wow. Oh. So that's all the notes we're going to take on Friday. Okay. So we're going to talk about the characteristics of urine because what you're doing in this lab, it's called a urinalysis. And so you have some urine samples from some patients, and you're going to be running them through a battery of tests to try and determine what's wrong with these patients. Some of them you might not be able to tell from their urine. Some of them you will be able to tell from their urine. Okay, so you'll have 4 patients that you're dealing with. And their history is also up on dashboard, as well as medical charts for you to fill out once you do different labs concerning these patients. So we're not going to have a chance to get through all of these labs by the end of the year because of all the snow days, but we'll do our best to fit a few of them in. So characteristics of urine. So just some general information about urine. Okay. The kidneys filter 150 to 180 liters of plasma every 24 hours. Okay. So all that plasma is going through the kidneys and is being filtered out. And we'll see on Friday that that's the first part of urine formation is filtering the blood, filtering the plasma. Okay. So the cells won't go into the urine, but we'll talk about that in a minute. Okay. So of that, only about 1 to 1.8 liters of urine is produced every 24 hours. That being said, depending on how much you're drinking, you might think, well, geez, I go pee like every 2 seconds. Depending on how much water you're drinking, depending on if you're drinking things that dehydrate you, that can make you produce more urine because they dehydrate you. So things like caffeine and alcohol, those things that dehydrate you cause you to produce more urine. Okay. So we say that the stuff that is initially filtered out of the plasma is the filtrate, and we'll talk about this Bowman's capsule thing on Friday. But that filtrate that's produced is plasma without the proteins. Proteins shouldn't be in there because they're too darn big, and they shouldn't be able to fit through the filter to produce the filtrate. The urine itself, by the time it gets to the end of this process, it goes through a process in the kidneys, and by the time it gets done and we actually get the urine, is a combination of nitrogenous waste and unneeded substances. Now, if we take a look at freshly voided urine, what should that look like? It should be clear and a pale to deep yellow. And how deep that yellow color is depends on how hydrated you are. If you're really hydrated, it's going to be on the pale side. If you're really dehydrated, it's going to be a deeper yellow, almost an orange color because of the dehydration, because so much water there's so little water in it, I should say. There's so little water in it, and it's just other things that are in there. And we'll talk about that, what those other things are. The reason why the urine is yellow is from a chemical, a pigment called urochrome, and it's a byproduct of hemoglobin breakdown. So that's what gives it its distinctly yellow color. Okay. Now, urine, now once again, we're talking freshly voided urine, okay? So when it first comes out of you, it is sterile and only slightly aromatic. Where it gets that nasty smell, that really high ammonia cell, is when the bacteria starts working on it. So that's what gives it a more distinct, what we associate with the urine smell. And so once it's out of the body, it's free reign for bacteria to start working on it and produce that awful smell. The pH of urine is approximately 6. Sorry, I couldn't find the little approximately sign, so that's the best I could do. So it's slightly acidic. There are some things that can alter the pH of your urine. Things, especially your diet, is a big one. So if you have a high protein diet, if you're on one of these like Atkins diets where there's really low carbs and high protein, that's going to make your urine have a lower pH, make it more acidic. And that's not necessarily a bad thing, it's just the way it is. Okay. If you have a high vegetable diet, or this increases the pH, bacterial infections can do the same thing, make your urine more basic. Now, obviously, bacterial infections are not something that we want, so that would be bad. But eating a lot of veggies, yay, go you. Veggies are good. Okay, I know I have some vegan friends out there. Okay, well, let's see. Urine is more dense than distilled water. Okay. So we talk about this in terms of specific gravity, and this is one of the things you'll be testing in the lab, or you did test in the lab. Okay. And so the specific gravity of water is 1.000, so just one. And we have three zeros places after that, so we have 4 significant figures. We're taking it pretty far out there. Urine, the specific gravity, and I have a page number on here, and I have no idea what that corresponds to in your textbook, whichever version you have of it. In my book, it's page 521 when they talk about specific gravity. Specific gravity of urine is between 1.001, so just very slightly more dense than distilled water, to 1.035. So a little bit more dense, still not a huge difference, but because it's not distilled water and there's other stuff in it, that's what's going to make the difference. So we have to be sure we test with distilled water when we do our testing on Thursday or next Thursday. Okay. So now I have a long litany here of what is in urine. So what is that stuff that's making it more dense? All sorts of stuff. We've got sodium ions. Sodium, of course, has a positive 1 charge. Potassium ions also has a positive 1 charge. Uric acid, urea, creatinine. Uric acid, urea, and creatinine are byproducts of protein breakdown. And so that's why when we look back up at the pH and we see that eating lots of protein causes the pH to go down, it's because we're producing more uric acid. So it's becoming more acidic. And then ammonia and bicarbonate, which have the opposite effect, they're both bases and they have the effect of raising the pH. But all of these things are in your urine. So now the fun stuff of if that's what is in their urine, what shouldn't be there? Once again, there's a chart. This is the page number in my textbook. I have no idea what page it's on in your version of the textbook. One of these days, that'll be my dream, that everybody in biomed will have the same version of the textbook, and I'll have a copy of it too. I don't think that's going to happen anytime soon, but it's a dream. All right, so first of all, glucose should not be in there. And for each of these, well, for some of these, we'll talk about non-pathogenic causes versus pathogenic. And so when we're talking about pathogenic causes, we're talking about things that can be related to disease or related to pathogens. So something like a bacterium is invading us, something like that. Okay? So with a couple of these, we'll talk about them in those terms of non-pathogenic. So that's just there's something other than a pathogen that's causing it, something other than a disease that's causing it. Okay. And then pathogenic. So with glucose, non-pathogenic, maybe you just ate a bunch of sugar. Okay, so you've got so much sugar in your blood that usually the kidneys will reabsorb that sugar back into the blood. We want to conserve that glucose. We like having glucose because our cells need it for energy. But if that doesn't work out, we have to get rid of some of it. So if there's too much, if you have excessive sugar intake, and the pathogenic would be diabetes. So if there's glucose in the urine, you might have heard of people who have diabetes or who were diagnosed with diabetes through their first inclination, of course, is that they have to urinate a lot, and then that urine, if it contains glucose, there you go. That's a sign. As I mentioned, proteins should not be in there because they're too big. Okay, the molecules are just too big to fit through the filter. And so a couple things are possible here. Non-pathogenic physical exertion. So you've been exercising a lot. That can cause proteins to kind of be squeaked through in the filter. Okay. But you're also breaking down proteins when you're exerting, and yeah, when you have a lot of physical exertion. So if you've been exercising a lot, you can have proteins in your urine. Fun thing, can also mean you're pregnant. I think you probably heard me tell this story before, but the old-fashioned, really old-fashioned pregnancy test would the over-the-counter ones would test for proteins in the urine, particularly albumin, and we talked about albumin in the last chapter. Um, so the thing was that you could trick them and get a false positive pregnancy test by eating a lot of eggs right before you took the test, within a couple hours of taking the test, because that would also get you more proteins in your urine. So I had an alum email me a couple of weeks before April Fool's Day and ask me, she said, I still remember you telling us that when we were freshmen, and I want to play a prank on somebody. So she went and she bought a pregnancy test at the dollar store. Don't know about that. But unfortunately, the modern pregnancy tests, even the over-the-counter ones, test for hormones in your urine and not for the proteins. So she was unable to successfully do that. Okay. So pathogenically, if you have proteins, it could mean that you have high blood pressure, or it could indicate a kidney infection. All right. So I mentioned earlier that the blood cells shouldn't fit through, that we're filtering the plasma. We're not filtering the whole blood, basically, because the cells, once again, they're too big. So if you have red blood cells in your urine, okay, so this would mean that you have blood in your urine, basically, whole blood in your urine. This indicates bleeding in the urinary tract. Okay. So it could be something like, I know you can't wait to talk about kidney stones, and so it could be something like that you passed a kidney stone, and so there's tears in the urinary tract. It could be something like that. But for whatever reason, there's blood and bleeding in the urinary tract. All right. Red blood cells, of course, are filled with hemoglobin, and hemoglobin doesn't belong in the urine. And so a couple things that this can, so notice with the RBCs and then with the hemoglobin the same way, I'm not going to say if it's pathogenic or non-pathogenic, because it depends on what's causing them. So it depends on what's causing the bleeding in the urinary tract. With the hemoglobin, it could be a transfusion reaction or hemolytic anemia. Now with hemolytic anemia, we've got that lytic in there, so we're talking about the red blood cells are bursting, something's causing them to burst, and it depends on what's causing them to burst if we would say it's pathogenic or non-pathogenic, so we're not going to worry about that. But interesting thing, I was doing some research on hemolytic anemia and different causes of it, and one thing that can cause it is snake venom, if you've been bitten by a snake. I thought that was kind of interesting. All right, continuing on with the cells, the white blood cells. If the white blood cells are in there, it's basically pus, which means that you have a UTI. Okay, so that's pathogenic, bacterial infection most likely. Remember that pus is a combination of dead bacterial cells and white blood cells. And yeah, lovely stuff. So the way that you would see this in a urine sample is if it's cloudy instead of clear, the way it usually is. And last but not least, bile. Bile doesn't belong in there. Bile belongs in our small intestine. What the heck? And as always, since the bile is produced by the liver, This indicates liver disease. All right. I think that about wraps it up on just a little overview about urine. So on Friday, we'll go back and take a look at the anatomy of the system and of the kidneys and see exactly how this urine is formed. And then on Monday, we'll talk about blood composition. Tuesday will be disorder day. Woohoo! And we've got a few of those. And then Thursday will be our test. So have a good afternoon, ladies. And now comes the time when I can't figure out how to turn this off.